Assalamu alaikum. How are you everyone? Today we'll start to review chemistry, grade 9, chapter 6, section 1. Chapter 6, section 1. The first question, choose the correct answer. Ionic bonds form as a result of the electrostatic attraction between dipoles, electrons, ions, and nuclei. Ionic bonds results from the electrostatic attraction between ions. Okay. The second question. A single covalent bond involves the sharing of only one electron, two electrons, three electrons, or a variable number of electrons which depends on the bonding atoms. Single covalent means each atom shares with one electron. So the two atoms share with two electrons. So the answer will be letter B. Use the table below to choose a pair of elements that will most likely have the least ionic character. Here, element sodium, electronegativity 0.9, chlorine 3, oxygen 3.5, and hydrogen 2.1. The least ionic character means the least difference in electronegativity. So, if you find the difference between each element and another one, between, for example, sodium and chlorine, 3 minus 0.9, it will be 2.1. Between sodium and oxygen, 3.5 minus 0.9, it will be 2.6. Between sodium and hydrogen, 2.1 minus 0.9, and so on. If you find the difference between each two elements, you will find that the least difference is between oxygen and chlorine, 3.5 minus 3. So the least metallic or ionic character. Question number 4. Use the table below to choose a pair of elements that will most likely have the greatest ionic character. The greatest here. The greatest ionic character means the greatest difference in electronegativity. If you find the difference between any two elements, you will find that the difference between potassium and nitrogen, 3 minus 0.8, it will be 2.2. So the largest difference between potassium and nitrogen, so choice A. To measure of an atom's stability to attract electrons, it is the measure of an atom stability to attract electrons is the atom's ability to attract electrons is electronegativity, polarization, ionization, or electron affinity. It is electronegativity. Choice A. Number 6. Atoms that are bonded with an electronegativity difference from 0 to 0.3 are generally considered to be negatively charged compounds, non-polar covalent compounds, polar covalent compounds, or ionic compounds. The difference electronegativity between 0.0 and 0.3. So it is the least difference in electronegativity. It will be non-polar compounds. Number 7. What is the apparent charge on the chlorine atom in the molecule HCl? HCl, it is a covalent compound. So, the difference. Hydrogen and chlorine. Chlorine will attract the electrons more than hydrogen, because chlorine has higher electronegativity than hydrogen, so it will attract electrons more to it. So the electrons are negative, so it will be partial negative. What's not negative one? Because it doesn't absorb the electron, it doesn't take the electron, but just the electrons are nearer to chlorine atoms than hydrogen, so it's partial negative. Atoms, number 8, atoms seldom exist as independent particles in nature because as single particles, most atoms have low potential energy. Their electronegativity is much lower than when they combine with each other atoms. Atoms are more stable when they combine with other atoms. Neutral particles are rare. So the choice will be, when they combine, will be more stable and less electronegativity, less potential difference after combining. Number 9, when an atom completely gives up its valence electrons to another atom, they form a bond that is considered to be purely ionic, partially ionic, polar covalent, non-polar covalent, give up valence electrons. So give up or loses its electrons, it will be purely covalent, purely ionic. Purely ionic. You can estimate the degree to which a bond between two atoms is ionic or covalent by calculating distance between the atom's nuclei, difference in the atom's electronegativity, atom's atomic radii, or number of atoms in the compound. So the choice will be the difference in electronegativity. Number 11, a chemical bond between atoms results from the attraction between the valence electrons and of different atoms. Different atoms what? The attraction between the electrons and nuclei, inner electrons, isotopes, Lewis structure. The attraction between the valence electrons and nuclei. A covalent bond, number 12, a covalent bond consists of a shared electron pair, two different ions, and octet of electrons. Covalent bond consists of shared electron pair, not one electron, it's a shared pair, at least two electrons. Number 13, if two covalently bonded atoms are identical, the bond is identified as non-polar covalent, polar covalent, ionic, dipolar. Two identical atoms means the difference in electronegativity equals 0. So they will be non-polar covalent. Number 14, a covalent bond in which there is an unequal attraction for the shared electrons is unequal attraction. So one atom attracts more. So it will be non-polar, polar, ionic, or dipolar. Unequal attraction. Unequal attraction means it will be polar. Atoms with a strong attraction for electrons, they share with another atom, exhibit atoms with a strong attraction for electrons, they share with another atom, exhibit zero electronegativity, low electronegativity, high electronegativity, or lowest electronegativity. They exhibit strong attraction means high electronegativity. More electronegativity, more attraction. Verse 16, bonds that possess between 5% and 50% ionic character are considered to be ionic, pure covalent, polar covalent, or non-polar covalent. Between 5% and 50. 5% means the difference in electronegativity equals 0.3. And 50% means the difference in electronegativity equals 1.7. So the difference in electronegativity between 0.3 and 1.7, it is polar covalent. The last question, the greater the electronegativity difference between two atoms bonded together, the greater the bond's percentage of ionic character, non-polar character, metallic character, electron sharing. The greater the difference in electronegativity. So the greater bonds percentage of ionic character. Okay, this is a review of chapter 6, section 1 in chemistry.